Hey everybody, I'm Chili. Welcome back to Beginner C++ Tutorial 21. Today's topic is going to be 2D arrays. First things first, we need a motivation. What's my motivation? Well, we haven't done the SNCC game in a while, so let's do something with SNCC. And if you remember back in the SNCC game video, I gave you an extra challenge of maybe, adding random obstacles that can appear in the game field. And if you run into them with the SNCC, you die. So I think we're going to do that. We'll tackle that challenge. Now, there are a few ways you could do that. One way is you could basically handle it the same way you handled the SNCC itself and the SNCC segments. So you could store the obstacles in a big array. And I imagine that's what most of you would have done if you attempted that challenge yourself. At least that's what I've seen. So in that case, you're going to maintain basically a big list of objects, and each object is going to know the location of itself. But the problem with this is if you have a lot of obstacles, then that means every time you move the SNCC somewhere, you're going to have to check every one of those obstacles. You're going to have to check its location compared to the location you're trying to move to see if there's a collision. So if you have a 100 by 100 board, and maybe 1/3 of the board is filled with obstacles, that's like 3,000 obstacles, and you have to check every single one of them every time you move the SNCC. I mean, a computer can handle that no problem, but it is kind of wasteful. Now imagine we have a big 2D array, and the dimensions of the array are the same as the dimensions of the board. So you've got one element in the 2D array for every space on the board, every location. And in this array, you can store information about what locations are currently being occupied by obstacles. If in this case, what we could do is when we're going to move the SNCC from, say, here to here, all we got to do is check the array at 5, check to see if it's clear. If it's clear, you move. If it's not clear, you're dead. So like in our previous case, you go from, say, 3,000 checks every move to 1 check. And that's pretty goddamn good if you ask me. Now, what if I told you you already have all the tools you need to do this? Let me break it down for you. So this is how we generally visualize a 1D array, right? So if we got an array and it has size of 12 elements, you got indexes going from 0 to 11, right? Now let's say this is how we're going to visualize a 2D array. It has 2 dimensions, so it doesn't have a single index. It'll have 2 indices, and I'll call them X and Y. X selects the column and Y selects the row. So let's number each of these elements in the 2D array. So we'll start from the top left and we'll go right and then down. So 0, 1, 2. All right, let's give each of the elements in the 2D array a number. We'll start from the top left. 0, 1, 2, 3, 4, all the way to 11. And we see here that this 4 by 3 array, 4 times 3 is 12, which is the same number of elements in this array here. So, look at these numbers here. They just line up if you go from left to right, top to bottom. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you can store this 2D array as a 1D array, and it looks something like this. So if we map this 2D array onto our 1D array, we just take these rows and lay them out one after another in the one-dimensional array. Now, the most important thing that we need to be able to do if we do this mapping is we need to be able to go from this X, Y coordinates to the actual index in the array. Like in our SNCC game, if we want to test the location 5 to see if there's an obstacle there, we have to be able to go from X and Y of 5 to the actual index in our 1D array. So how do we do that? Well, the first thing you should notice is that the first element of every row, it starts 0, then it's 4, then it's 8. You start to see a pattern here, and the pattern is the index of the first element of every row is basically just the Y coordinate of that row. So 0, 1, 2 times the width of the whole array. So for example, this one here, y is 1. 1 times 4 equals 4. Here, y is 2. 2 times 4 equals 8. And for the y of 0, it's 2 times 4 equals 0, right? Same idea. So in general, to get the first element of any row, you take y times the width. Now what if I don't want just the first element of any row? What if I want the next one over? Well, if you want the next one over, you add 1. And look at this. The x-coordinate of the next one over is 1. So you add the x-coordinate and you get the next one over. If I want the 2 over, I add 2, x-coordinate of 2. So here you see, if we add x, we can get the offset into any row. If x is 0, that means just add nothing, just take the first element of the row, which is just y times width. But if I want the next element over, I would add 1, x-coordinate of 1. There you go. If I want the x of 3, I would add 3. So you just add the x, which is the offset, into the row. So let's do a quick test here. Let's say I want to get the element at 3, 2, which is x of 3, y of 2. Well, that is just y times width. So 2 times 4 plus 3, 8 plus 3 equals 11. And that's here, which is the last element in our 1D array, which is what you'd expect because it's the bottom right of our 2D array. So this is how you go from 2D coordinates to 1D coordinates. And this system of laying out the rows in a 2D array, one after another in a 1D array, this is called row major mapping. So we're mapping the rows one by one into the 1D array. And it's the most common mapping that you're going to run into. There's also column major, but it's not as important. And this idea of mapping onto a 1D array, this is how basically everything is mapped, like 2D grids, 3D grids. And the reason why is because in the end, memory is just a big 1D array, right? Memory, each location that you store data into, we call that an address, and it's just an index into an array. So no matter how we structure our data in our heads and in our programs, in the end, it all ends up in a big 1D array. All right, let's get down to it. I'm going to create my branch and we'll get started. So taking a look at the board class, I think this is where I'm going to want to put my array for the data about the obstacles. I know in the original Snake tutorial, this class was all about drawing the board. It didn't have any logic in it, but I think it's time to add some logic to the board. So let's create an array of bools, and we're going to call this array, we'll just say has obstacle. Now the size of the array is going to have to be the width times the height of our board, right? So there we go. Bool has obstacle width times height. All right, now let's initialize the array of bools so that all of the elements are initially false. There's a number of ways we could do this. We could loop through all of them in the constructor, but this is the easiest way, probably just a single brackets and then one false, and this will tell the compiler to initialize every element in this array to this value, which is false. So this will initialize everything to false. Now, what we want to do is we want to create a function that can test a location to see if it contains an obstacle. So I'm not sure what I'm going to name this one. I'll go bool check for obstacle. And what we're going to do is we're just going to put a constant location in here. And the function itself is also going to be const. It's just a test. So check for obstacle, and let's make that motherfucker. All right, so what are we going to put in here? Well, what do you think we're going to put in here, viewer? I mean, we're going to return has obstacle. And now we just got to do our 2D to 1D mapping. So this is going to be location.y times width plus location.x. And that should be it. That's all she wrote, basically. Now let's add a function to spawn a random obstacle. I'm going to make this function take a random number generator and the snake. The reason for the snake is because we don't want to spawn an obstacle on top of our goddamn snake. That's dumb. So we'll do this. All right, before we go any further, we've got a little bit of a problem here. And the problem is, well, I mean, first off, this H file here, this header for board, it doesn't know about the random number generator. And it doesn't know about snake. We can include random. That's easy. And that'll fix this problem. But snake is a little more, it's a little trickier. And here's the rub. And I've talked about this a couple times already. But snake.h includes board.h. So if we were to make board.h also include snake.h, they would be including themselves, and that is just going to create a bullshit storm of goddamn garbage. Like, let's try it. All right, I've included snake.h in board.h. Let's try to build it. And we get errors. We get lots of errors. Can't do it. It's not going to work. You can't have headers that include each other, board including snake and snake including board. That's just garbage all the time. Now, what you can do is you can include, let's just promote this to a full document. You can include snake.h in board.cpp. That's fine. And now board.cpp knows about snake, so it's happy. But board.h, it still doesn't know about snake. So it doesn't know what a snake is at this point. And if I try to build this, you're going to see we still get some errors here. Board.h, missing type specifier. It's expecting a type name, but it doesn't know about snake yet. So it's like, what the fuck is this bullshit you're putting before this thing here? Doesn't know. So what are we to do? Well, here's the thing. At this point in the compilation, when this is included at the top of the CPP file, we're not doing anything with snake yet. We're just at this point, we're just saying, okay, compiler, there's this function called spawn obstacle. It takes one of these things and one of these things, but we're not actually using the snake until board.cpp. And here we can include snake.h. So it's all fine. So all we got to do here is we just got to tell the compiler, okay, dude, listen, there's this class. It's called snake. And the function here, spawn obstacle, is going to take one of these snakes. I'll tell you all about snake later. But for now, all you need to know is that there's a class called snake and you'll be fine. And then later on, when the compiler gets down to here, in spawn obstacle, it's already going to have included snake.h and everyone's going to be happy. As long as your headers don't include each other, it's fine. Your CPP files can include basically whatever the fuck they want. And this thing I did right here is called forward declaration, and it's quite important, and we'll be using it, fairly often. Basically, whenever you want to have a situation where board does something with snake, while simultaneously snake is doing things with board, you're going to have forward declaration somewhere. There are other advanced ways of solving this problem, but forward declaration is the simplest one. So we include random, we forward declare snake, and then in board.cpp, we include snake.h, and let's spawn an obstacle. Now, basically, we're going to be doing the same thing that we did with the goal respawn, whereas we generate a random location, and then we check to see if that location is okay, if there's nothing in there, if there's no snake. And if not, we just keep doing her. So what I'm going to do is I'm just going to motherfucking copy this shit. And then we're going to go back to spawn obstacle. We're going to paste that in here. So we can just replace, we don't have to put board.get. We just call get grid width and get grid height. These are member functions of the board. Subtract 1. And there we go. We've got our distribution of the coordinates. Create a new location. New location.x is equal to distribution is. New location.y is equal to that. And we keep doing that while snake is in tile. Now we could also check to see if there is an obstacle there. So while snake is in tile, or check for obstacle. So if check for obstacle returns true, that means that there's an obstacle there. We need to generate a new random location. And when we find a location that isn't overlapping with anything, then we can do has obstacle at y and x equal to true. So we set it to have an obstacle. Now there's one more problem that I just thought of. What happens if we spawn an obstacle on top of our motherfucking goal? That's probably not going to be good. You're not going to be able to eat your fruit. You're going to be pretty hungry, goddamn snake. So what we're going to do is we're going to add one more in here. We're going to go constant goal and %goal. Now, this file doesn't know about goal, so we got to include goal.h. So we include goal.h, and now it knows about goal, but there's a problem. And the problem is now this doesn't match the function declaration. So we go into here, we add goal. So far, so good, maybe. Let's try to build it. Missing type specifier int assumed. Well, we know what this means. So if we look at goal, we see indeed it does include board. So we can't include goal into here. But what we can do, we can go constant class goal. Hey compiler, there's this class called goal. I'll tell you all about it later in board.cpp. Right here. Build that shit. And now we succeed. So now we have to add one more condition to our regeneration of the location. So we go check for obstacle is in tile or goal dot get location is equal to new location. So if any of these conditions are true, try again and keep doing so until you get a good location, and then set the obstacle in the obstacle array there to true. So this will allow us to spawn an obstacle. Now we just got one more thing here. We need a function we're going to go back to board.h. We need a function to draw all of the obstacles. So we'll go draw obstacles, and we don't need to pass in graphics because I've maintained a reference to graphics here. So we'll do that. And give me my light bulb. All right. So in here, we're going to loop through all of the y's and then all of the x's. And for every location, we're going to check to see if there's an obstacle there. And if so, we're going to draw a gray rectangle. Actually, wait a second. In board.h, let's add another const expression here. We don't have enough, you see. And we'll call this one obstacle color. And we'll set that equal to gray. And so we'll use the obstacle color to draw the obstacle. Yeah, let's scroll over here. Okay, so we need for looping through y and x. And of course, we're looping from 0 to height in the y and 0 to width in the x, not including width. The locations are from 0 inclusive to width exclusive, for example. And in here, we just do if, what is it called? Check. If check for obstacle, there it is. We need to create a location here, so I'll just do curly brackets for the location and XY. That will create a location. So if check for obstacle in here returns true, then we want to do cell, I believe is what it is. You're supposed to auto-complete that for me. And we need a location. So again, we'll do X and Y. And we need a color, which is going to be obstacle color. There we go. So we're going to loop through every single cell coordinate on our board. And if we find an obstacle there, we'll draw that motherfucker. Now we could select, a number of different triggers that would add new obstacles to the board. But I'm just going to do the easy one. Instead of like creating a new timer or something, I'm just going to make an obstacle get added every time we eat some fruit. So we got to figure out where the goal is. The snake counter will move, else get location, move by. Grow and move by, respawn, eat.play. All right, so what I want to do here is we grow, we respawn, then we go board, BRD, yes, dot, spawn obstacle, and we pass it the RNG, and we pass it the snake, and we pass it the goal. I hope that's the name of the variable, I can't remember. All right, so here we'll be spawning obstacles. All right, the next thing we need to do is we need to draw our obstacles. So we're going to go down to compose frame, if game is started, blah, 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 else, draw. Okay. So what we want to do here is draw board.draw. It doesn't matter the order really, but we're going to draw obstacles. And last but not least, going back up here, we have to check to see if we hit an obstacle. So if snake is not inside board, or if snake dot is inside tile except end. This is basically the check to see if the snake collides with itself, or here's if it collides with the outside of the board. Next, what we want to do is we want to go board dot check for obstacle, and next. So here we got our 3 death conditions: the wall, the snake itself, or an obstacle. And if we build this stuff, it should work. And if we run it, we got the snake. Do it. All right, we're right at the end of the wall here. Don't die. Hurry up. Ain't got no goddamn day here. Oh, we got a freaking obstacle, man. Let's try to commit suicide right away. Let's do this suicide thing. And there you go, game over. You have been destroyed by the obstacle. And there you go, that's how you do it. I mean, you create a 1D array, and you make it size the width times the height of your grid. And then, all you gotta do is when you wanna access some bullshit, you do y times width plus x. And there you go, you've got your location in your 1D array. And the other thing we learned, which I didn't actually expect to have to teach at this point, is forward declaration. And that basically allows 2 classes to refer to themselves. You don't have to include snake in here in order to use snake, for example, in your function declaration. And then when you get to the definitions of the functions, you can include snake in game.cpp. That's fine, just as long as your headers don't include each other. And if you want to know why headers including each other causes problems, you just got to go to my tutorial 18. I talk about that shit. But anyways, this is how you avoid making your headers include each other. You do forward declaration. You tell the compiler, hey dude, there's this class called snake. I'll tell you about it later. Now, 2 things before I get to the homework. Number 1 is this is not the only way to do 2D arrays. However, this is the most flexible way to do 2D arrays, and that is why I'm teaching it. And that's the only one we're going to be using. The other ways, they have some advantages in some situations, but for the most part, just storing everything as a 1D array and then figuring out the 2D to 1D mapping yourself will give you the greatest flexibility. You can use that in any situation, whereas the other ways, they can't be used in certain situations and they're all fucky and I don't like them. I'm going to put a link in the wiki page to an article that shits all over the other styles of 2D arrays, and you can read that one if you like, but I'm not going to waste time talking about it here. Now, the second thing I want to say is that this idea of 2D arrays and thinking of your data as being organized in a 2D grid is super important, because think about it. The pixels on a screen, all that shit is a 2D grid. And let me show you something kind of interesting. If we go into graphics.cpp, we go to our holy put pixel, the mother of all of our graphics. we see that, in fact, it looks like we're accessing an array here. And we're accessing it by doing y times the screen width plus x. And we're just assigning the color, the put pixel color, into the array here. So there you have it. All that put pixel is just this 2D array shit that I've shown you. And that's all basically any graphics is. It's all just accessing this 2D array of pixels and doing shit. Of course, there are more details to it and a whole bunch of other bullshit, but when you boil it all down to the basics, that's what it boils down to, accessing a 2D array of pixels, which is really just a 1D array that we're organizing. All right, now it's time for the homework. The homework challenge for you is going to be, I want you to make poison snake. What is poison snake? Well, glad you asked that question. Here I present poison snake. So it's pretty simple. You've got these purple squares which are poison, and if you move over the poison squares, the snake will speed up. If you grab the goal, the snake will get longer and an obstacle will be spawned. So you want to definitely avoid the obstacles, but you also want to avoid the poison because it's going to make your snake go faster. Let me show you. Grab a couple of them. You can see it's going a little faster now. Now, the snake starts off really goddamn slow, and that could be like a pain in the ass. So I added, if you press the control key, you can speed the snake up like this. So you got a little bit of a speed control. If you want it. You just keep grabbing shit, and as you grab more shit, your snake gets longer. As you go over the poison, snake gets faster. Let me just grab a bunch of poison here. All right, now we're moving. And as you can see, it quickly becomes pretty much impossible to control. If you eat too much poison, you're gonna die. But yeah, that'll about do it for today, I think. We learned how to map a logical 2D array onto a 1D array, and we learned how to do circular dependencies with for declaration. As usual, if you have any questions, comments, you can hit me up on the Discord, on the forum, or in the YouTube comments. I hope you enjoyed the video. If you did, click the like button, it helps a lot. And I will see you soon with some more C++.